So when I was making these videos, there's like aspects of this type of chemistry that I really love, and there's aspects I find incredibly tedious. And so I find the theory of aromaticity incredibly tedious, and I don't like making videos on it because I feel like I have to break it to 50 videos to make the concept successful. But I love talking about the reactions of aromatic compounds. So my reward, keep in mind that as you're watching these videos, you'll probably notice a tone difference. When I'm talking about aromaticity, I'm like, but when I'm talking about reaction, I'm like, yeah, it's awesome. So these videos are my reward for like slogging through the videos on how to do aromaticity. Now, why do we care about the reactions? Well, this is really the practical part of organic chemistry. The theory is useful, it explains a lot, but in practice you care more about the end result. Now, what we need to talk about in terms of reactions are twofold. One, how do we actually perform reactions? And two, and this is the more difficult concept here, how do we direct where they go? So let's say we have some benzene ring. And we're not going to draw it out with a ring, we're going to draw it out with just an R group. Now, the question is, what positions are more relevant? And to do this, we're going to pretend that there is a lone pair accessible on this particular R group. And it's going to be kind of an illustrative point, but we're building to a picture here. So if I were to take this lone pair, kick it down, I would move the lone pairs there. So this ortho position now becomes accessible for having lone pairs. You can act like a Lewis base. Now I can further resonate to get the lone pairs down, and hopefully this is high enough for you. We end up getting this structure. And this can further resonate back and forth. To give us this, and this can resonate back to give us that. Now, what's the point of drawing out these resonance structures? Well, here's the thing. If we have any R group attached to the benzene ring, by resonance, there are only two positions which are actually affected by resonance. And this is your ortho and para positions. So the ortho and para positions here are the only two positions that are directly affected by whatever R group is attached by the ring. And again, this is a resonance argument. So, when we talk about directing groups, the R group here is what is directing. Now the question is, how does it direct? Well, the reactions we're going to perform are reactions that are based on that lone pair existing, that benzene ring being able to act as a nucleophile, or something being able to act as electrophile, attracted to where those lone pairs are. If our R group adds electron density to these lone pairs, meaning that it's an electron donating group, this will make these ortho-para positions much more attractive to electrophiles. If the R group is electron withdrawing, meaning that the electronegativity or something about that group withdraws electron density from it, it'll make the ortho and para positions less desirable. Now, what makes something ortho-para directing versus meta directing? Well, the question is, how desirable are the carbon atoms in the meta position? So if our electron donating group is making these ortho-para positions super electron rich, it's more likely then to react with the ortho-para positions than it is to react with the meta positions. But if whatever our R group is really good at pulling electron density away, it's going to make this more likely to react with the whatever we're trying to react with next versus the ortho-para positions. So this is what gives rise to directing groups. If we have a directing group that adds electron density, it's going to make the ortho-para positions more desirable. If it withdraws electron density, it's not that it makes the meta position more desirable. It just makes the ortho-para positions less desirable than those meta positions, so the meta position is more likely to react. So, with that in mind, now we can start talking about how these R groups direct subsequent attachments to a ring.